Hello everyone, welcome back to our video series on database management system. And in today's video I am going to explain you very important topic of database management system, which is normalization. Okay, so generally just creating table in database is not really help. Okay, what we have to do, we want tables but in the organized way. Okay, organized way means what? Whenever you want to insert data, whenever you want to delete data, whenever you want to modify some data, okay, do some operation on that, it should work properly. Okay, for that we require normalization. Normalization is nothing but it is the process of organizing data in the database. Okay, database is collection of table, but just adding the tables in the database will not work. We have to add the tables but in the organized way. Clear? Why we use normalization? Normalization basically used to reduce the redundancy or the duplication. Okay, and to eliminate the undesirable characteristics. What are the undesirable characteristics? So there are different anomalies: insert, update and delete anomaly. Anomaly means what? There is something which is not working properly. Okay, insert anomaly is what? Whenever you want to insert data in the table but your data cannot be inserted, that is, your insertion is not working properly. Clear, right? Deletion anomaly means what? Whenever you want to delete some data, a particular value I want to delete, but by deleting that particular value some other value also getting deleted. So that should not happen, right? If I want to delete a particular value, that value should only be deleted. And if it is indirectly deleting the unintentionally it is deleting some other value, then that is the problem. Correct? And updation anomaly is same like the delete anomaly. If you want to update a single record and because of that update it requires to update more than one records or multiple records are getting updated, then this is the problem. Correct? So to reduce this drawback, we require what? Normalization. Understood? So normalization is nothing but the process of reducing the redundancy and the duplication in the tables. Correct? What we do in normalization, we divide the larger tables into smaller tables using relationships. Clear? Now there are some rules whenever you want to check whether your database or whenever you want to create your database and normalize. We have to follow those rules. Okay, that rules are nothing but the normal forms, right? So different normal forms are there in the normalization. Correct? Normalization work through the series of stages called normal forms. These normal forms apply to individual relation. Relation is nothing but the table, and the relation is said to be in particular normal form if it satisfy all the conditions. Clear? So first normal form. What is first normal form? Whenever your relation, when you will say that relation in first normal form, when it has all atomic values, single values. Okay, so no two attributes or a cell can contain, a single cell can contain only single value. No two values are allowed in a single. Like that, let's say this cell is having 1 NF. This field is having 1 NF value. If I write here 1 NF comma 2 NF, this is not allowed. Okay, each field will have a single value, atomic value. This is first NF. So in first normal form, what we will check, whatever tables we have to check the values. All the values, all the attributes and all the fields are having one value, atomic value. Clear? Second NF. The first NF is very easy to identify. Next is 2NF. 2NF is a relation will be in 2NF if it is in 1NF. First is it should be in 1NF. If it is in 1NF, then we will go for 2NF. All non-key attributes are fully functionally dependent on primary key and not on the part of primary key. Okay, in short, there should not be any partial dependency. Okay, there should not be any partial dependency. Now what is partial dependency and what are this prime attribute and non-prime attribute, non-key attribute? Okay, so let's take an example. Okay, I have one table. Okay, and that table is having 3 attributes A, B and C. Okay, that table is having 3 attributes A, B and C, and let's say AB is my primary key, or you can say the candidate key. Okay, and this AB is my candidate key. Then A and B both are my prime attribute. Attribute which are part of candidate key or a primary key are called as prime attribute. Understood what I am telling you? I have one table. In that table I have 3 attributes A, B and C. Okay, and if in that table I have AB as primary key, AB as primary key, so the attribute which are the part of primary key are my prime attribute. Attributes which are the part of primary key. So A and B is the part of primary key. These are my prime attribute. Okay, and attribute which are not part of primary key is my non-prime attribute. So C here, C is my non-prime attribute. Okay, now what is written in the rule? There should not be any partial dependency. Okay, here it is written all non-key attributes are fully functionally dependent on primary key and not on part of primary key. So my non-prime attribute is C. It should be dependent on full primary key and not on part of primary key. So if I write here AB C, means C is functionally dependent on AB. AB is my primary key. Yes, this is allowed. Okay, but if I write A implies C, C is dependent on a part of primary key. A is a part of primary key, but it is not the entire primary key or a candidate key, correct? So A is part of candidate key, which is partial dependency. Okay, so my non-prime attribute is partially dependent on primary key and which is not allowed in 2NF. Understood? Very important topic. You get the questions on this. That you have to identify the database is in which normal form. Okay, so first normal form is you have to check whether all the values are atomic. In second normal form, what you have to check? You have to check whether it is in first normal form, first thing, and the second thing you have to check, there should not be any partial dependency. And what is partial dependency? I have explained you. You have to identify the primary key. Attributes which are part of primary key are the prime attributes, and attributes which are not part of primary key are the non-prime attribute. Okay, if your non-prime attribute and functional dependencies are given in the question, they give you the functional dependency. You have to check whether your non-prime attribute is dependent on the primary key or it is dependent on the part of primary key. If it is dependent on part of primary key, it is not in 2NF because this implies the partial dependency. Clear? This is about the 2NF. Next is 3NF. 3NF is a relation for like 2NF. First the relation should be in 1NF and 2NF both, then only it can be in 3NF. Okay, so first you will check for 2NF. If it is in 2NF, if it is in 1NF, then we will go for 3NF. Okay, 3NF says that there should not be any transition dependencies. There should not be any transition dependencies. Now how to check the transition dependency? It is very simple. As you know what is prime attribute and what is non-prime attribute. If in any dependency there is non-prime to non-prime, if at any dependency there is non-prime to non-prime, it indicates that it is transition dependency or it is transitive dependency. Clear? If there is one condition is that if there is non-prime to non-prime, it is transition dependency and it is not allowed in 3NF. If any of the dependencies will have this type of dependency, then directly it is not in 3NF. Clear? For example, we have 4 attributes here, A, B, C, D. Okay, let's say AB is my candidate key. That means AB are my prime attribute. And C and D are my non-prime attribute. Okay, what we have to check? Non-prime to non-prime is not allowed. Okay, prime to prime is allowed, but non-prime to non-prime is not allowed. So here we will check C and D. C implies D. So D is dependent on C and C and D both are non-prime attribute. So this type of dependencies are not allowed in transitive dependency or in the 3NF. Okay, understood what is there? Okay, in short, what we have to remember is whatever is there on the LHS. Yes, whatever is there on the LHS will always be primary key. Okay, whatever is there on the LHS, it should always be your primary key, candidate key, or a super key. Then only you can say that your database is in the normalized form. Okay, and there is BCNF. Okay, boys code normal form. It is the stronger definition of the 3NF. Okay, what you have to check at the end for BCNF, you have to check the a very important condition. Whatever is there on RHS, we don't know. Okay, but your LHS should always be the super key, candidate key, primary key. LHS should always be the super key, candidate key, or a primary key. Okay, so this is about the normalization. Understood? Okay, thank you.